Hey, Math 6 students, this is your teacher, Mr. Plunkett. You guys gotta get off the SpongeBob. You gotta start doing a little math. Today, what I figured I'd post is it's a very just specific video on solving equations that have fractions as coefficients to the variable. So U, O, and K on the worksheet that we did in class have those. So I'm hoping you're able to do this. Maybe I'll do one of these in the video, but it'd be great if you could learn the concept and do it on your own. And so to teach you that, I'm going to go to a blank page and see if you can learn it based off of what I write here. Okay, I bet you know how to solve this. 4 times x is equal to 12. If I said solve that, it means find all the values of the variable that make that true. I know you probably already know, right? I always put the line through the equal sign, that x is equal to 3, right? No big deal. Okay, how do we prove that x is equal to 3? Well, what operation is 4 doing to x? 4 is a coefficient, so it's multiplying x. And the inverse of multiplication is division. And we use a fraction bar to show division. So we're going to divide both sides using the division property of equality. We're going to divide both sides by 4. And the reason we're going to do this is because on the left side, 4 divided by 4 is 1. That's 1x. I don't need to write the 1 there, but there is a 1 there. And indeed, that's what we want to know. We want to know how much 1x is equal to. Not 2x's, not 3x's, just 1x. And of course, 12 divided by 4 is 3. Well, what if you have something a little bit different? What if you have something like this? 3 over 5x is equal to 9. Oh, I think that's one of our problems, isn't it? Isn't that one of our... Oh, wait, no, it's not. Well, that's close, though, so this will help you. 3/5 x equals 9. Well, let's see. What's similar to our last equation? 4 was multiplying x. Guess what 3/5 is doing to x? Yep, it's multiplying. I totally missed with that multiplying dot right there. It's multiplying the x. So when we had multiplication, the inverse operation to undo the multiplication was division, right? Well, we could still think of this as, let's divide both sides by, well, we divided by the coefficient of x, which was 4. We're going to divide by the coefficient of x, which is 3/5. I guess I should have done these in blue, huh? That's probably what you're thinking. That's what I'm thinking anyway. Okay, and then you go 3/5 divided by 3/5. I hope you guys know what that is. It's 1x. I probably shouldn't put my line through. Equals. Whoa, what is going on here? Technically, this is 9 over 1 divided by 3/5. 9 over 1 divided by 3/5. So I can do that down here where I have some space. 9 over 1 divided by 3 over 5. Well, dividing fractions. How do we do that? I remember. Multiply by the reciprocal. You multiply by the reciprocal of the divisor. This is the divisor thing you're dividing by. And the reciprocal is 5/3. So we get 9 over 1 times 5/3. The 3 cross cancels with the 9. And you get 15. Okay, but if you're really, 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 really on it, you might see something. And in fact, I'm going to get rid of our other example here so we have some space so we can compare it to what we just did. If you're really on it, you'll see that at the very beginning, when we had 3/5 x equals 9, you go, okay, I'm going to divide both sides by 3/5, right? Well, dividing by 3/5 is the same, down here you can see it, dividing by 3/5 is the same as multiplying by 5/3. So instead of going through this whole process of showing dividing by 3/5 and having these confusing fraction sandwiches, or fracwiches as I call them, they're actually called complex fractions. Instead of doing that, what if we did this? What if we did 3/5 to x. I don't know if I should do it that way, or let's just do it this way. This will work too. Multiply both sides by the reciprocal of 3/5. Oh, 9/1 times 5/3. How do I do? Oh, I can make that into 9/1 and then multiply that by 5/3. We're using the multiplication property of equality. I know that's confusing because there was multiplication between 3/5 and x, but the fact is we just want a 1 in front of the x. This is 3/5. By multiplying 3/5 by its reciprocal, you're going to end up getting a product of 1. So the product of those two factors is 1. And if you multiply the left side by 5/3, the left side of the equation by 5/3, what do we have to multiply the right side by? 5/3. Watch what happens. Here's why a fraction times its reciprocal is equal to 1. The 5 cross cancels. The 3 cross cancels. I know it looks weird having the x there, but these are all just being multiplied. So you can do this. You can cross cancel like this. You get 1/1, which is just 1x. And if it's 1x, do I need the 1 in front of it? No. I could write this as 1/1. I could also write it as 1x or 1x, like that. Now on the right side, you cross cancel. 3 times 5 is 15. When you multiply fractions, you go straight across. Numerator times numerator, denominator times denominator, and you get x equals 15. Now, in class, I've been pushing us to learn how to do it this way. Whenever you have a fraction that's the coefficient of the variable, you multiply both sides by the reciprocal of that fraction. Just because, look, otherwise you get these fracwiches, and you might have to show the work down here. It's just a lot more steps. So hopefully you see that this is the best way to go. And it looks like I still have time on the video, so how about we tackle one of these? Okay, 9/10 x equals 9. I could divide both sides by 9/10, or I could multiply both sides by the reciprocal of 9/10. I'm going to do this one, because it might look a little confusing having the variable on the right side of the equal sign instead of the left side. So I'm going to put a little line through here. Obviously that went over too far. That's okay. Okay, 1/2 x. The coefficient of x is 1/2. Typically we would divide both sides by 1/2 because the inverse of multiplication is 1/2. Or sorry, it's division. But instead, because it's a fractional coefficient, I'm going to multiply both sides by 2/1. And I know this is going to look weird, but you can do it, and I'm going to explain why. Wait, how do I multiply by 2/1 if this is just 20? Oh yeah, I can make this into a fraction by putting it over 1. And I like putting parentheses to show the multiplication. Okay, there's an x in the middle. That doesn't matter. Because these are all being multiplied, you can actually cross cancel across factors. That's okay, even though you have this in the middle. This would be now the same as x over 1. 1 times x times 1 is x. 1 times 1 times 1 is 1. That's x over 1. Don't need to show that. 1 times 1 is 1 in the denominator. We'll just go to the numerator. 2 times 20 is 40. And it looks like x was equal to 40 all along. To prove that, if 40 and x are the same thing, go back to the original equation. What's 1/2 times 40? Well, check over here. 1/2 times 40 is the same as 1/2 times 40 over 1. If you multiply straight across, you get 40 over 2, right? 1 times 40 is 40. 2 times 1 is 2. 40 divided by 2 is 20. And so 1/2 of 40 is 20. Exactly what we wanted. All right, if you have any questions, as always, you can ask on Google Classroom or you can email me. You are all amazing. Keep up the amazing work, and I will see you more on the online world soon. Bye.